A potentiometer, often known as a pot or a potmeter, is a free-terminal mechanically driven rotating analog device that can be found and utilized in a wide range of electronic projects. By watching this video, you will learn the working principles of a potentiometer and how it is used in the most common electrical circuits. Okay, let's get started. A potentiometer is a manually adjustable variable resistor, and it is so useful when it compares to a fixed resistor. Why, you may ask? Imagine we have a 100 ohm fixed resistor. If for any reason we decide to change the resistance, for example to 200 ohms, we have to change the resistor itself. We need to get a new value resistor, and that's where a potentiometer comes in useful. Here you can easily change the resistance value just by turning the knob on top of the potentiometer. Let's have a look at the different parts of a potentiometer. First, it is better to remove the potentiometer cover to see the inner structure as well. A potentiometer has 3 terminals or connection points, among 2 are fixed and 1 is variable. The 2 fixed outer terminals are connected to both ends of the resistive element, formed into an arc of a circle responsible for establishing an electrical resistance. You should note that the maximum resistance of a potentiometer is placed inside the semicircular pattern. The variable middle terminal is connected to a sliding contact, often referred to as a wiper, attached with a rotary knob. It means whenever we turn the knob, the wiper will run across the resistive element, results in making good electrical contact. Now let's find out how a potentiometer works. To do this, we use one of the most beloved industrial tools, the multimeter. Imagine our potentiometer has a resistance of 10 kiloohms. So, if we hook up the 2 outer terminals to the multimeter, it shows the maximum resistance of the potentiometer, that is 10 kiloohms. Now I connect one side of the multimeter to the middle terminal and the other side to one of the outer terminals of the potentiometer. This way, the resistance value that the multimeter shows depends on the position of the wiper over the resistive element. If we adjust the wiper in such a way that increases the resistive path between the measured outer terminal and the wiper, the resistance increases. And if we set the wiper in such a way that decreases the resistive path, the resistance decreases. Note that if we connect another multimeter's probes to the middle terminal and the other unused outer terminal of the potentiometer, the sum of the resistance shown by these 2 multimeters is equal to the maximum resistance of the potentiometer. To fulfill your learning, you need to know how the potentiometer can be connected in different configurations in the most common electronic applications. If only the middle terminal or wiper and one of the outer terminals of the potentiometer are used, it will act as a variable resistor. In this application example, we use a potentiometer for brightness control. Here we connect the wiper to the positive terminal of the power supply and one end of the resistive element to the positive side of the LED. As you may know, the amount of current flowing through the LED determines its brightness. If we turn the potentiometer in a way that increases the resistance, the current flow decreases, thus the LED will become dimmer. And if we adjust the potentiometer in a way that decreases the resistance, the current flow increases, thus the LED will become brighter. Now let's switch to another application example where all 3 terminals of the potentiometer are being used in wiring configuration. This way, we can say the potentiometer will act as a voltage divider. In this diagram, we use a potentiometer for motor speed control. Here we apply a reference voltage across the whole length of the resistive element and connect the wiper to the DC motor. This way, by turning the knob and controlling the position of the wiper, we can allow enough voltage to pass through the potentiometer. If we adjust the wiper in a way that introduces a high resistance, less voltage will apply to the motor, causing the DC motor to turn slower. And if we set the wiper in such a way that introduces the low resistance, more voltage will drive to the motor, resulting in turning the DC motor faster. That's all we have for you today. We hope you got familiar with the basic concepts of a potentiometer.